Hi everyone, this is Mr. Lennie from Impact Circle, and today we will be exploring the laws of indices. The first and most popular law is as follows: a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. So let's see how this works, right? So we need to know that a to the power of m actually is a times a times a, and so on. And how many copies do we have? We actually have m copies of a multiplied by a, right? And a to the power of n is actually the same thing, a times, and so on. And we have n copies of a. And when these two things are multiplied together, we're just going to take the top multiplied by the bottom. But each and every one of these signs are multiplication. So it doesn't really matter whether it's from the left group or from the right group. It's actually one big group, right? And so what do we have? We actually have a total of m plus n copies of a multiplied by itself. Okay, this will actually give us a to the power of m plus n. Okay, let's take a look at a simpler example. If we have a to the power of 3 multiplied by a to the power of 2, the first term is actually a times a times a. 3 copies of a multiplied together. The second term is a times a. 2 copies of a multiplied together. And in the middle, we have the operation multiply as well. Right? So we actually have 3 copies of a multiplied by 2 copies of a. Okay? And in total, we have 5 copies of a multiplied together. And therefore, this is the same as saying a to the power of 5. All right? The common mistake is that you choose to multiply the powers instead of adding it up, right? But if you think carefully, because you have 3 copies on the left and 2 copies on the right, the total number of copies is actually 5 copies. So there you have it. am multiplied by an equals to am plus n. Okay, for the next law, it's pretty similar to this one, right? It goes a to the power of m divided by a to the power of n equals a to the power of m minus n. Sometimes you also see it in this form, am over an equals am minus n, right? So these two mean the same thing. So let's see how it works, okay? So just like before, what is a to the power of m? A to the power of m is really just a times a times a, and so on. And you have m copies of a. And at the bottom, same thing. So this is m copies, okay? The bottom you have a times a times a, and you have n copies, okay? And I'm just going to assume for a moment that m is greater than n, but actually it doesn't make a difference, all right? Let's assume that m is greater than n. This means that there are more copies on top compared to below. So because everything is factorized, you are able to cancel one on top and cancel one below. Okay, which is actually what you're doing is you're dividing a on top and below, right? So you keep canceling on top, below, on top, below, on top, below, on top, below. And because m is greater than n, you have some left over on top, which haven't not been cancelled. So how many copies are you left on top? Right? you are left with actually m minus n copies. And therefore, this means that after cancelling, the result will be a to the power of m minus n. And you have your second law of indices. Right? Let's look at a specific example now. Let's assume you have a to the power of 7 divided by a to the power of 3. Right? So you have a fraction where on top you have a times a times a times a times a times a times a. 7 copies on top. 7 copies. Okay? And you have a times a times a below. 3 copies. And now let's do our cancellations. Cancel 1 on top, 1 below, 1 on top, 1 below, 1 on top, 1 below. And how many copies are you left with on top? You are left with 7 minus 3 equals to 4. And this will give you a to the power of 4. So you can see how this works. And if you remember in this way, you don't really have to memorize, right? Try your best to memorize by understanding rather than memorize by memorization. Okay? If you can have this picture in your mind, it makes it much easier to memorize because you understand how the laws work. Okay, next up, the third law goes like this. You have a to the power of m to the power of n is equals to a to the power of m times n. Okay, so for this, I'm going to use a simpler example to illustrate. Okay, so let's use a squared to the power of 3. Okay, so what does this mean? This actually means that we have a squared times a squared times a squared. Right? That's what power of 3 means. The number multiplied by itself 3 times. Okay? 3 copies of it, right? But each of these groups of a squared is actually a times a. This is a times a. And this is also a times a. And because of this, you can see that actually what we have is that we have 3 groups of 2. But let's remember that all these are multiplication, and it doesn't really matter because all of them are the same sign. It doesn't matter whether the multiplication is in this group or in that group. Everything is multiplied together. So what do we have? We actually have a total of 3 times 2 copies of a. And this gives us the result that a squared to the power of 3 will be the same as a to the power of 6. Okay? So for this law, you multiply the powers together. For the first law, remember the first law? We add the powers together. So just remember this distinction between the two laws. Okay, awesome. Okay, let's move on. And now with the initial 3 laws, we can use those 3 laws to come up with the rest of the laws. Okay, so next up, what is a to the power of 0? Okay, it might not be immediately apparent to everyone, right? But let's use the second law. What does the second law say? The second law says am divided by an is equals to am minus n. So let's just choose. Let's just choose a general value, right? Let's choose both to be 2. Okay? Let's put in 2. So what do we have? We have a squared divided by a squared equals to a 2 minus 2, right? And by the way, what is a number divided by itself? If you take a number divided by itself, what do you get? You always get 1, right? You always get 1. Okay? So you must know this general principle. The number divided by itself is 1. So these two are the same numbers. You divide it by itself, the left side will be equal to 1. But what does the right side become? 2 minus 2 is 0. So the right side becomes a to the power of 0. And there you have it. A to the power of 0 is equals to 1. Okay? So if you forget, just remember, play around with the first 3 laws of indices, and you will be able to figure out if you happen to forget. Okay? Especially in the stressful exam conditions, right? You might forget. Right? But if you understand how it works, you will never forget. Okay? Okay, the next law. Okay, how about a to the power of 1? A to the power of 1 is just a. Okay, I think this is pretty simple. Right, so I will not spend much time on this. Okay, it's just one copy of a. Okay, next up comes the few laws that are more confusing to most people. All right, we actually have a to the power of a negative power. All right, so now with this, let us use the first law. Okay, what does the first law say? The first law says that am times an is equals to am plus n. All right. Okay, so what we're going to do? We're going to change this instead to a negative n. Sorry, negative m. Right, and we're going to change this to a to negative m. Right. So we're using the first law, right? But we are changing it such that it is negative. All right. So let's see what happens. On the right side, we have m minus m, which is 0. Okay, and as we have just found out, a to the power of 0 is 1. Right? So what we have is this. We have a to the power of m multiplied by a to the power of negative m equals to 1. This means that a to the power of negative m, if we divide both sides by am, will be equal to 1 over am. This shows you that a m and a negative m are reciprocals, right? So similarly, a to the power of m is also equals to a divided by a to the power of negative m, right? Both of these are the same, okay? The same meaning, right? So just remember, a negative power is 1 over the same thing but positive power, right? Negative power is 1 divided by the positive version, right? Or in other words, a to the power of m and a to the power of negative n m are reciprocals. Okay, reciprocal. Okay, so a simpler example with this: 3 to the power of 2 is 9, but 3 to the power of negative 2 will be equal to 1 over 3 to the power of 2, which will give you 1 over 9. Okay. So by the way, the common misconception is that a negative power is a negative number, but this is not true. Okay, you can see this is a negative power, but it's actually a positive number. Okay, so let's just give a few more examples, just to be sure. So 7 to the power of negative 2 will be equal to 1 over 7 to the power of 2, which will be 1 over 49. Okay, 2 to the power of negative 3 is actually 1 over 2 to the power of 3, which is 1 over 8. Okay, so a negative power gives you a fraction, right? And don't forget, the other the other way also holds. So 2 to the power of 3 is equals to 1 over 2 to the power of negative 3. Yeah? So it can be the other way around as well, right? Because why? Because this is actually equal to this, right? Which is 1 divided by 1 over 8. And you use your primary school keep, change, flip. Keep, change, flip. Okay, and this is actually equal to 8. Yeah? Which is 2 to the power of 3. Yeah, so you have to remember both ways. Awesome. Okay, next up, we've done negative powers. Now let's do fractional powers, right? And for fractional powers, okay, you have to remember it in this way. Let's take the first law. Okay, let's say we have 7 to the power of half times 7 to the power of half. Using the first law, this will be equal to 7 to the power of half plus half, right? Which will give you 7. 7 to the power of 1. Okay, now you have two numbers, the same numbers, multiplied together to give you 7. So what must each of these be? By definition, each of these numbers will be the square root of 7. The square root of 7. You multiply together, it will give you 7. Does that make sense? Right? Let's use the easier square root. Okay? Let's use 9 to the power of half times 9 to the power of half. And this should give you 9 to the power of 1. Right? So you have two numbers multiplied together, the same numbers, to give you 9. What must each of these be? It has to be 3, right? 3 times 3. Okay? So you can see that actually 9 to the power of half is actually equals to the square root of 9, which is 3. Okay? So just bear in mind that when we are dealing with these laws, um, the square root will be the positive square root. Okay? I understand that you might be told if you square root both sides, you need both positive and negative. But when you're using these laws of indices and you take the root, it's always considered to be the positive root. All right? Okay, so you have a half times a half is actually equals to a. All right? Okay, now how about if it's 1/3 instead, right? Let's say you have 8 to the power of 1/3 times 8 to the power of 1/3 times 8 to the power of 1/3. And now you need 3 copies to give you 8 to the power of 1, right? Because 1/3 plus 1/3 plus 1/3 is equal to 1. So you need 3 copies multiplied together now, right? So each of these, what do they have to be? Okay, right? So yes, it has to be the cube root of 8. The cube root of 8. The cube root of 8. And what is the cube root of 8? Okay, so the cube root of 8 is an easy number. It's actually 2 times 2 times 2. And yes, this will give you 8. Right, so the general result is this. If you have a fraction, a to the power of 1 over n, this one will be the root. Okay, so this will be equal to the nth root of a. The nth root of a. So just remember, the denominator of a fraction power represents the root. Yes. Okay, finally, we have this, the general fraction. So the bottom represents the root. The top represents the power. Okay? So just remember, this is equal to either this to the root n, or you can take the root n first to the power of m. Either way is fine. Okay, but normally what I recommend is you take the root first. So you take the root first. Why is this so? Because it's easier to make the number smaller rather than bigger. Okay, I'll give you an example. Let's say you have 8 to the power of 5 over 3. Okay? So this is the power, and this is the root. So can you imagine if you do the power first, are you going to be able to do 8 to the power of 5? Can you imagine how big this number will be? Okay, and even after you do it, are you able to cube root it? It's going to be very difficult, right? Right. So instead of doing the power first, we're going to do the root first. So we're going to take the third root first, and then we do the power. Okay? So what's the third root of 8? Really, it's just 2. Okay? And we're left with 2 to the power of 5. And 2 to the power of 5 is much more easily done than if you try to take 8 to the power of 5. Am I right? Right, so what's 2 to the power of 5? It's just 32. Okay, you can see how much simpler it is to make the number smaller before making it bigger. So this is my general advice to all my math students. If you have a choice, make the number smaller first. Do the divide first. Then you do the multiply. Okay? Make the number smaller first. It will make life easier for you. Right? And there you have it. We have the laws of indices. We're actually left with 2 more laws, right, which are not so common. Okay, so let's cover it now. Okay? So the other laws go like this. Instead of having the same base, now we have the same power. Right? So you have a to the power of m times b to the power of m. And now you can see the powers are the same. So what does this mean? This means that we have a times blah, 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 blah. And we have m copies of a. But we also have m copies of b. We also have m copies of b. And because this is times, and it doesn't matter which order we multiply, like 3 times 2 is the same as 2 times 3, okay? Doesn't matter, we can actually shift things around. So instead of having all the A's first and all the B's first, we can actually have one A, then one B, then one A, then one B, and so on. Okay? And each of this is actually, we are able to group it together to be AB times AB times AB, and so on. And how many copies of AB do we have? Because we have m copies of A and we have m copies of B, we have a total of m copies of AB. Does that make sense? So we actually have m copies of AB. All right? And what does this mean? This literally means that this is equal to AB to the power of m. Okay? So if you are very familiar, you know the concept of powers very well. It's very easy to understand this. Okay? You will never forget. Okay, similarly, we have a to the power of m divided by b to the power of m will be equal to a over b to the power of m. All right? And the proof is pretty much the same. Right? We have am over bm. Right? And on top, we have a times a times a and so on. Okay? M copies. At the bottom, we have b times and so on. Also m copies. And because these are fractions, we can actually split it up. We can actually split it up to a over b times a over b times a over b. And we have m copies. Therefore, this gives us a over b to the power of m. So there you have it. We've covered all the laws of indices. And please make sure that you know these very well because these are very, very important and will be used for many topics. Okay, so what are the laws again before we go? Okay, we have am times an equals am plus n. We have am divided by an equals a to the power of m minus n. Okay, we have a to the power of m to the power of n equals a m n. We have a to the power of 0 equals to 1. We have a to the power of 1 equals to a. And we have a to the power of negative m equals to a to the power of 1. Sorry, my bad. 1 over a to the power of m. Okay. Similarly, a to the power of m is also 1 over a to the power of negative m. Both of these are true. Okay. And now we have fractional powers. So we have a to the power of 1 over n is equals to the nth root of a. The nth root of a. And we have the general um, fractional power, which is a to the power of m over n is equals to a to the power of m and then to the root of n. Okay, or a to the power of, sorry, the nth root of a, the whole thing to the power of n, either way. Okay, and the last two will be a to the power of m times b to the power of m equals to a b to the power of m. And finally, we have am divided by bm is equals to a over b to the power of m. So these are the laws of indices. Even though they might be very complicated, they might seem like there are a lot. But just remember, the first three are the most important. This one and this one. And with this tree, you can actually come up with all the rest. Right? So there you have it. Until the next time, this is Mr. Lennie here from Impact Circle Education. Bye.